Chapter 10, Example 5. 57 students participated in a lottery for a particularly desirable dorm room, a triple with a fireplace and private bath in the tower. 20 of the participants were members of the same varsity team. When all 3 winners were members of the team, the other students cried foul. Could an all-team outcome reasonably be expected to happen if everyone had a fair shot at the room? So let's run a simulation to answer this question. Once again, we're not going to list the component, the response variable, the trial, all that stuff. We're just going to write in a narrative form how we're going to perform this simulation. Once we've done that, we will use technology. We'll use a random number generator to run our trials, and then we will state our conclusion. I want to determine the probability of randomly selecting 3 students from the same team of 20 students out of 57 participants. To do this, I will use a random digit generator, generating numbers 1 through 57. I will generate 5 numbers at a time in case of repeats which I need to skip. A repeated number would represent selecting a student that had already been picked. A trial will consist of looking at 3 unique numbers and recording whether 3 students on the same team were selected. This means I would record a trial as yes. 3 numbers selected are between 1 and 20. I'll record a no otherwise. I will run 50 trials and find the proportion of trials with a yes result. In this case, we're going to use technology. And the nice thing about technology is I don't have to use just single digits or pairs of digits or 3 digits. I can tell it to pick numbers 1 through 12 if I wanted, 1 through 98. In this case, since there's 57 students, I'm going to tell it to generate numbers 1 through 57 to represent those 57 students. And then I'll tell it how many numbers to generate at a time, in this case 5, to account for any duplicates. So how I'm going to do this is I'm going to go to the calculator. From the home screen, I'm going to do a new document, and I'm going to do a calculator page. Then we select Menu, Probability, Random, and we want Random Integer, not Random Number. Random Number gives you decimals, so I want a random integer. And then we have to put in our values that we want. I need to tell it what numbers to select and how many to select. So I want to start with 1, so I put 1, and then comma, 57. So that says start with number 1 and generate any random number up until 57. So I can pick any numbers between 1 and 57. And then I'm going to do comma 5. And that means generate the numbers 1 through 57 and generate 5 numbers at a time. Then I just hit enter. And that first time gives me 26, 32, 15, 40, and 50. Now the first 3 numbers are all unique. There's no repeats. So I just need those 3. 26 and 32 would be somebody not on the team. 15 would be a team member. So I have not picked 3 people on the same team. So I would mark that trial as a no. The nice thing about doing this on our calculator is now all I have to do is hit enter again to do my next trial. If I hit enter once more, I get 49, 46, 13, 16, 37. Again, the first 3 numbers, there's no repeats, and I would get 2 people not on the team, and the third person would be on the team. So again, that trial is going to be marked down as a no. I'll repeat this so I get my 50 trials. The third trial, I get 53, 28, 11. So once again, 2 people not on the team, 1 person on the team. I went ahead and ran 50 trials, and I had 6 occurrences of 3 people from the same team. So that was 6 out of 14, which means I can calculate that proportion. I would do 6 divided by 50, and that comes out to be 14%. So now I want to clearly state my results. My simulation of 50 trials shows on average I could expect to select 3 team members 14% of the time. Since I predict these results would occur 14% of the time, I conclude this outcome is possible, and there is not enough evidence to suggest the selection process is unfair. So 14% is a big enough number that we would say, that can happen by chance. If it was maybe 1 or 2%, then we might consider these results very unusual. If we did the lottery 100 times, I would expect 14 of those times to have just 3 people on the team selected. Now, if we don't trust these results, we could run more trials. If I did 100 trials, or 1,000 trials, or 10,000 trials, the more trials I do, the closer we'll get to what the actual proportion would be, what we would call the theoretical proportion. So you can always run more trials to become more confident in your answer.